Assalamualaikum and good day everyone. So today we go to chapter 3.2, Ohm's law and resistivity. For learning outcome 3.2, you have to state and use Ohm's law. Ohm's law states that the potential difference across a metallic conductor is proportional to the current flowing through it if the temperature is constant. Mathematically, we have V directly proportional to current where T is constant, or in formula we have V is equal to IR, where R is the resistance of the conductor. Figure shows the potential difference V against current for the metal or conductor, where we have V is equal to IR. So when you compare with straight line equation, Y equal to ms plus C, your Y is your V, your X is your current, and your gradient equal to R. But then if you have I versus V, we have I versus V, we have V equal to IR, I equal to V over R. So you have compare it with the straight line equation. Let's see, your Y is your current, your X is equal to your V, and then the gradient equal to 1 over R. So this is your graph. Ini is 1 over R. Okay, so for the outcome 3.2b, you have to define and use resistivity. Ini adalah simbol resistivity, which is rho. Rho is equal to RA over L. So for the resistance, we have R. For the resistivity, we have rho. Okay, we look at resistance first. Resistance is defined as the ratio of the potential difference across an electrical component to the current passing through it. So we have R is equal to V over I, where V is the potential difference and I is current. It is a measure of the component or position of the flow of the electric charge. It is a scalar quantity and the unit is ohm. If the temperature of the metallic conductor is constant, the resistance is also constant. So then we can conclude that R is directly proportional to T. Alright, so we go to resistivity, which is the symbol is rho. Okay, resistivity is defined as the resistance of a unit cross-sectional area per unit length of the material. Mathematically, we have rho is equal to RA over L, defined as the resistance of a unit cross-sectional area, okay, per unit length L. It is a scalar quantity and the unit is ohm meter. It measures a material's ability to oppose the flow of an electric current. And then remember that the resistivity depends on the type of material and the temperature. Okay, different material has their different resistivity. A good electric conductor has a very low resistivity, and a good insulator has high resistivity. Okay, we look at this table. Okay, so here the resistivity for which one is very high. Okay, kita nak tengok kat sini, kita ada aluminium. Aluminium is 2.82 times 10 power of negative 8. Kita ada silver 1.59, copper 1.68, and gold 2.44. Okay, so kita kat sini. From the equation, rho equal to RA over L, the resistance of a conductor depends on the length in a cross-sectional area. The resistance. The resistance is R lah. Okay, the resistance R equal to rho L over A. So R depends on the length and the cross-sectional area. Sectional area, rho ni hanyalah depends on the type of material. Okay, so kalau kita boleh tengok kat sini, different type of material has their own resistivity. Okay, remember the good electric conductor have very low resistivity. Okay, which one kita tengok? Good electric conductor, very low resistivity. Okay, very low resistivity, silver. Okay, itu adalah good electric conductor. And good insulator, very high resistivity. Good insulator adalah kita punya poor conductor. Poor conductor, very high resistivity. Okay, yang mana very high? Kita ada very high is aluminium. Okay, aluminium kita punya good insulator. Good insulator. Okay, so seterusnya. Okay, for example, number 3. When a potential difference of 240 volt is applied across a wire of 200 cm long, the current per unit area. Okay, so I over A is 7.14 times 10 power of 9 ampere per meter square. Calculate the resistivity of the wire. Okay, so we have rho is equal to RA over L. Okay, dia nak cari resistivity of the wire given that the current per unit area. Okay, so daripada sini R kita tahu V is equal to IR. So R equal to V over I. Okay, V over I. So rho equal to V over I area, and we have length. So we have rho, V is 240, area, I is 7.14 times 10 power of 9, L is 200 times 10 power of negative 2. Okay, so your rho or your resistivity is 1.68 times 10 power of negative 8 ohm meter. Okay, so we look number 4. Two wires P and Q with cross-sectional area section are made of same metal. Okay, same metal meaning the rho is same and have an equal length. So L is also same. If the resistance of wire P is 3 times greater than wire Q, okay, so RP is equal to 3 RQ. Determine the ratio of their diameters. Okay, determine the ratio of their diameters. So RP is equal to 3 RQ. So rho P L P over AP is equal to 3 rho Q L Q over AQ. Okay, so we know that area equal to pi d squared over 4. Alright, so we have rho P. Okay, rho P the same kan. Okay, rho P LP AP pi dP squared. Okay, this one 4 3 rho Q LQ over 4 juga ni pi dQ square. So kat sini darab 4 lah, 4. Okay, so sekarang ni kita punya rho and L is same. Okay, so we have 4 dP squared equal to 12 over dQ square. So determine the ratio of the diameters. Okay, so kita nak ratio dP over dQ. Okay, dP over dQ. So dQ squared per dP squared equal to 12 over 1. So dQ squared over squared equal to 3. So dq over dp equal to set of 3. Okay.